It could be worse. So you know what happened yesterday? There was one additional corona victim discovered in California. You've heard the news.
Yeah.
That was at the hospital where my sister-in-law just went back to work after her maternity leave.
Oh.
Could be worse, right? Yeah.
Yeah, my best friend's a perfusionist, so she keeps everyone's heart alive during surgery, and they always fit them all for respirators because she can't just not do it.
Yeah, it's getting scary.
Stay healthy.
Yeah. Yay, Iowa!
There are perks to being out in the middle of the nowhere.
It's true. Yeah. I don't know. It's been one of those days. I gotta focus. All right, coming back in. All right, let's talk about homework. Baby, let's talk about homework 3. Things and the bad things that I asked you to do. Does anyone have questions? It's due next Friday. Not this Friday, but a week from Friday. I'll start there.
What's the
Hit
difference
me.
between model scale and data scale?
Whether you're predicting in the link, which is model scale, like a logit outcome, a log outcome, etc., or you're predicting the back-transformed version of it that is the expected mean, such as the expected count, the expected probability, that stuff. Sure. Other questions? Yeah, I just answered a homework question. It's what you get for showing up. Try to do you some favors. No questions? Not yet? Okay, well, I'll keep asking. We do have a quiz to go over. So I looked at your answers, and looks like the first 3 questions went reasonably well, and the 4th one went off the rails a bit. So we'll talk about that. But this is exactly why I want to do this, is so I can check in to see what misconceptions folks have, and it actually foreshadows the next unit so nicely. So I got to do that. So we'll start here, formative assessment 3. So you already have the answers to this written down somewhere. If you'd like to edit your answers, you can make a new entry. That's fine. I've already given you the points. So first question, for what kind of outcomes would the Poisson and negative binomial conditional distributions be appropriate choices? What kind of outcomes? Counts. Yeah. More generally, discrete outcomes that are bounded at 0, right? So counts are sort of prototypical. I'm sure there may be others. What are the extra concerns regarding 0 values that you got to watch out for? Okay, 0, too many zeros or not any zeros, right? So if there's not any zeros, then you need a special version of the distribution, which Lexi just said, 0 altered or 0 truncated means a Poisson or a negative binomial without zeros in it. They just adjust the total area to take away whatever would have been expected. And what about if you have too many? Then what can we do? 2 options, yeah, 0 inflated. So there are 0 inflated versions in all of the things that we were talking about. What does that do? If you want to fit a 0 inflated model, what are you adding to your analysis? Another submodel that predicts what? The logit of being an extra 0. Yeah, it's a logit link in a Bernoulli distribution because that part of the model is binary. And that is the case regardless of whether it's a 0 inflated count model, where the rest of it is a Poisson or negative binomial, or a 0 inflated binomial or beta binomial, in which the rest of it is some sort of binomial something. I haven't said this yet, but even in the continuous ones like log, normal, and gamma, zeros are a concern, but we can't have a 0 inflated version because there's no zeros in those distributions to begin with. So if there's no, what can we do instead that we can also do the version of the model that I like better? And Alfonso, you said it. Goes with the gesture. Hurdle models. What are hurdle models? Ding dong. I'll let another zoomer in. Hi, Hancy. What are hurdle models? Remember? We haven't done any in our class examples yet. I've been saving them.
Is that the if and how much one?
If and how much, yeah. A hurdle model takes the zeros out of the distribution. And so then you're predicting the logit of being a zero of any kind, just zero or something else, in one submodel with a logit link and a Bernoulli distribution. And then the rest of it is predicting the non-zero values specifically. So if you were to do that with a count distribution, you would need a zero truncated or zero altered negative binomial or Poisson for a count. You would need some kind of zero truncated binomial, which I don't even think is a thing. At least it's not something I've ever seen before, even though it's theoretically possible. Beta could be used for that instead. And in the continuous case, there is, you can have a hurdle part to predict whether or not you're a zero, and then if not a zero, a continuous. So this actually is a whole slide that I put that we haven't talked about yet. Pile of zeros taxonomy. This is slide 15. So what kind of amount do you want to predict? If the amount is a count of events, those are your three choices that we've discussed: Poisson, negative binomial, and there's something else called generalized Poisson that is less commonly available. It's a version of negative binomial where the stretchy factor isn't bounded at zero. If you're trying to predict the number of events out of a total, that's binomial or beta binomial. And if you're trying to predict an amount that's continuous, such as response time, money, stuff like that, you can use beta because beta is bounded between 0 and 1, log normal or gamma. And then from there you have to decide what do you want to do with the extra zeros. So if you want to predict an extra structural zero, as they call it, beyond that is predicted by amount, then you need a regular discrete distribution with the zero inflation submodel. So the difference between a zero inflated model and a hurdle model is where the zeros go. In a zero inflated model, the zeros stay as part of the count, and you're only predicting an extra zero. In a hurdle model, you move all the zeros to the zero model, and you only predict the counts above zero. Of those two, the hurdle variant, I think, is more interpretable, because in reality, there is no such thing as an extra zero. All you have for each outcome is just whether or not it's zero. The continuous ones would have to be, it's known as a two-part model, that's what it's called, but it's a hurdle is the concept. So you're predicting if it's zero and then how much if not zero. So there was a paper, and I didn't add it to this class, but I was thinking about it. For instance, if you have wearables where people measure like the number of minutes of vigorous activity, like those sorts of studies, have you seen these before? Where are these? It's a big thing, people want to measure activity. Well, a lot of times those sorts of distributions from measures of activity have a giant pile of zeros, where people are sitting or sleeping or something like that, and then there's some distribution after that. So if you were to put a two-part model or a hurdle model to something like that, it would be like, are you moving at all? Yes or no? And then if you're moving, how much? How many minutes? And so that would be a little bit more useful than trying to come up with some sort of inflation version of that. But yeah, we got to worry about bringing it back, having no zeros or having too many. And those are problems to watch out for. Okay. Questions on number 1? All right, next question. What is the role of a log link, and when would you choose a log link instead of a logit link? So first half, what does a log link function do? I think you all got this right, so go ahead and read what you wrote in front of me. Yeah, it keeps the expected counts positive. That's the way I would phrase it. Yeah, predicted counts, I'll take as a substitute. Yep. That's what it's for. So when you unlog, the expected counts stay above 0. In what situations would you choose a log link instead of a logit link? Yeah, log is when it's bounded below. So if it can't go past 0, but it can go into positive infinity, Logs are designed for that situation. What situation are logits designed for? Both. Yeah, bounded above and below, so to speak. So such as proportions, right? Or any outcome that has a floor effect and a ceiling effect. The logit makes it so that the predicted outcomes on the model scale go on forever and ever, but when you unlogit it, they stay within the boundaries that you set for the model. Yep. Good. What kind of outcomes would binomial beta and beta binomial be appropriate for? Proportions, yeah. Things with boundaries above and below sort of more generally, I think you could make an argument for, but proportions as the sort of prototypical case. And what are the concerns regarding zeros and ones? So first off, do binomial distributions allow zeros or ones? Yes, they do. Could you have too many? So you could test a zero inflated binomial model. In theory, you could test a one inflated binomial model, although I couldn't figure out how to do it in software, but it's theoretically possible. How about beta? Does beta allow zero or ones? It does not have zeros or ones as part of its distribution. So if you're using beta, you'd have to put something else in there as another submodel to predict zeros or ones. And beta binomial. What's that one for? Stretchy. Stretchy what? Stretchy binomial, yeah. It's when the variance exceeds what it's supposed to be according to binomial. So you can think of negative binomial is to Poisson as beta binomial is to binomial. They're sort of working the same way. So
Wait,
yeah.
go over what
Yeah.
we use just to
Beta is the only thing that I know of that could fit a bimodal distribution. There is a paper about that in Psych Methods maybe 10 years ago that I saw. That's the one instance. The parameterization of it is really tough to understand, though. I've never attempted to use it in anything. The only context in which I've seen it is the beta binomial as a mixture type thing. So, but yeah, that's the bimodal data in theory. Okay. Any other questions on the first three? Okay, so number 4. So typical linear regression, meaning any kind of general linear model. So that would be linear regression, analysis of variance, analysis of covariance, any of those words. They all say that the model residuals are supposed to be independent, normally distributed, and have constant variance. So my question to you is, how do the generalized models that we've talked about so far, such as for binary outcomes, categorical outcomes, count outcomes, proportion outcomes, and now lately continuous outcomes that are skewed, how do those models address those three concerns, or do they? So first off, normality. How do our models fix this?
We specify conditional distributions.
We pick a new one, yeah. So when you hear people say that this assumes normality, it means that the normal probability distribution is what they're using to come up with the likelihood. That's the formula that creates height. The log likelihood formula is a transformation of it to make the math easier, but the concept is the same. That's the height formula. So we say, okay, we're not going to use the normal distribution as our height formula. We're going to swap in Bernoulli, multinomial, Poisson, negative binomial, binomial, beta binomial, etc. Right? We'll just swap that out. And so now, each of those distributions has rules about how the mean and the variance are supposed to work together or not. The normal distribution is one of the only ones that has a mean parameter that is completely separate from a variance parameter. And so we're focusing on predicting the mean and seeing how much variance is left in all of those models. Whereas, say, what happens in Bernoulli? What happens to mean and variance? How are they related? It does. It does.
Bernoulli has a variance?
It says they're related. It doesn't have a separate one.
Oh.
Yeah, in Bernoulli data, the mean times 1 minus the mean is the variance. So that means two things. The variance is not a separate number that has to get found like it is in normal, and it's not a constant number. So the normality and constant variance go together in the sense that the normal distribution says that there's only one variance, it's separately estimated and holds for everybody. Bernoulli says, no, 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 no. I don't need to know the variance because once I know a mean, I'm good. And the variance is going to be highest if the mean is 0.5, and it shrinks as you move away from that. How about Poisson? What does that say about the mean and the variance? They're the same. What does negative binomial say about mean and variance?
Variance can't exceed.
It allows it to exceed the mean, but by a particular function. It multiplies the mean squared, the stretchy factor does. So the mean and the variance are quadratically related in negative binomial. So it has to find the stretchy factor, that's the multiplier, but beyond that it specifies a mean variance relationship that's more typical in count data. So it's non-constant still. How about binomial? Does that have a separate variance? Nope, it's the same. It's the mean times 1 minus the mean times the number of trials. That's your variance. And that's why Poisson and binomial are subject to over-dispersion, because they're the only ones that don't have any wiggle room. Like the mean and the variance are tied together and there's by a rule. Things that allow that rule to be changed, multipliers, stretchy factors, those things deal with over-dispersion a little better. There's a gamma is another one where the variance is a quadratic function of the mean, where the multiplier that makes that happen is estimated by the model. So again, non-constant variance is part of that. But we haven't talked about this word, independence. Does switching to binomial or Bernoulli or multinomial or Poisson or negative binomial or beta binomial or gamma or log normal, or I think that's all of them, beta, sorry I forgot that one, does that solve independence? No, it does not. In every instance of the examples we've seen so far, we have a sample of people who are supposed to be independent. It's not longitudinal, it's not repeated measures, it's not clustered, it's not anything. Because generalized linear models work the same as general linear models in that regard. If you're going to sum up the log likelihoods of each person, given whatever formula for height, the only way that that's cool to do is if people are independent. So that's where we're headed next week, assuming I can get my lecture done, is what do you do instead? And it works out pretty straightforward if you're willing to still say things are normal. Then it's an easy fix. If you're trying to work with any of the other models, it's not so easy.
I have a question about
Yeah.
independence.
Yeah.
So when we put them into, I guess I was thinking more about like correlations among variables when you put them into the model.
Mm-hmm.
Do they allow for that? For some reason I thought they did.
They do.
Okay, and that's, isn't that different than linear? Like Jen, the OLS.
So my question was about the model residuals specifically.
Okay, so that's,
Yeah. All of these models handle the correlation between predictors. They give you the unique effect of the predictor. That doesn't change because the linear predictor functions the same as it does in regular regression. It's the linear predictor predicting log count or logit this or whatever, but that part is exactly the same. So if the predictors are correlated, it takes that into account in estimating the slopes and the standard errors of the slopes more specifically. So yeah, this is just about the residuals.
So like if we were to do like a cluster model, that's what an account, that's what takes into account. Okay.
You have to build some way into the model to tell it that certain E's get to be related to each other, those that belong to the same sampling unit. And if you're dealing with multiple outcomes, potentially they each need their own version of a residual variance or their own version of a stretchy factor or their own something to allow a variance to differ across outcomes. So those are the two things that we have to solve in moving from univariate models like this to multivariate models. Yes. All right, questions on any of that? Okay, then let me pull up the stuff that you sent me. We're going to have a workshop. I didn't send this size to you. I only have 2 responses. We're going to do a live thing for a few minutes at least. Because I asked you guys for stories that we could help us try to figure out how to use the models in this class. Because my homework is always like, fit a count model, right? Fit a binomial. But when you're faced with the data set, you got to make those calls. You got to figure out which way to go in terms of what family, and more importantly, how to set up the model that actually answers your questions. And so I got 2 responses. Kelly sent me something and Hansi sent me something. I think she's on Zoom today. Let me see if I can find her. Let me see, where's my participants? Yep, Hansi's there. So she, it'll be a little trickier. She raised her hand. You're here. Thank you, Hansi. I'm going to have to try and see if I can get her to be on the audio here in just a minute here, but we'll start with Kelly. So Kelly sent me this. You have a paper that's under progress,
Yes.
in progress, with adolescents trying to predict 3 different kinds of outcomes, right? Whether they harm themselves, they harm others, or they harm everybody.
Yeah.
And so was this, can you give us just a brief, how are these data collected? How did they come to you?
Oh, this is gonna be way harder. So it is a cluster sample. So
Okay,
that's probably just ignore.
we'll ignore that for today.
So it's a cohort study of adolescents. So every 3 years they're interviewed from birth until now they're 18.
Okay,
So it's a whole interview and it has all sorts of things, and self-harm and harm to others is one of the big things. So we're interested in how gender plays a role in whether or not people, and specifically girls versus boys, internalize their stressors, and say bullying is one of the stressors that we're interested in. And then if some other harm others, or else if they do both simultaneously.
okay, so you have children measured, is this a cross-sectional in that they're all like one age, or you're following them over time? Okay, so it's longitudinal. That's what you mean by clustered? Or children are...
Clustered is they're within wards within countries.
Oh, it's longitudinal and clustered?
Yes.
Oh boy. Okay.
Dissertation, yeah.
Yeah, so we're going to ignore that for today because we haven't talked about any of that, but we can focus on just the sort of the linear model aspect. So you're thinking of this as 3 categories,
Yes.
right? What made you choose 3 as opposed to harm selves, yes or no, harm others, yes or no, as 2 distinct outcomes?
Well, we did play around with them as 2 distinct outcomes, but we wanted them all together because harming both themselves and others, so like, they're not all exclusive, they're like, they overlap, I guess is what I'm saying.
Mm-hmm.
So that's why we wanted to see them all together.
Okay, so
Does that make sense?
I think so. So inarguably, this is worst,
Yeah.
right? Hurting everyone is the worst thing you can do.
But the first 2 is where we didn't, where it's not gonna be work call.
Mhm.
Because we can't really order like, which one's worse, harming yourself, and you're still harming yourself.
Yeah, so it's like these 2 are sort of on equal footing, harming
Right,
yourself or harming others, and they're both the top one is worse than both of those. So you're trying to then see how gender plays a role in these behaviors. Let me stop right there. So are boys more likely than girls to fall into one of these categories, or vice versa?
Yes.
What do you expect?
We expect that girls are going to internalize and harm themselves, boys are going to externalize and harm others.
Okay, I'm going to add some notes here. Equals internalize, harms others equals externalize, and harm both is both types of problems.
It's gonna be probably,
Yeah.
Yeah, that's the big one.
How's that? Okay, so if we're going to write this out as a model, and so this is nominal then, right? Is that the way you're thinking of it? Who would you like to have as your reference group
Yes.
for the outcome?
Oh, for the outcome.
For the outcome.
None. There's no harm at all.
Oh, that's another category?
I mean, yeah. Sorry. I guess I automatically assume.
No harm
Yeah.
equals happy face. Harm selves, harm others, or harm everybody. So we have y equals, we'll call it harm self instead of none, like that. And then we have y equals harm others. Or m equals harm all instead of none. All right. So each of these needs an intercept. Let's go. I'm going to put, I go back and forth on how to notate these things, but at a minimum, I think I need some subscripts for which submodel we're in. So I'll put that there, that there, that there. And this one will be S for self, O for others, although I really don't like that. And then A. Don't do this to people, your readers, but I can't come up with something else. What, can you give me a synonym for others that I can work with here?
Yours?
Okay, P it is. That's much better. Okay. So girls are more likely to harm themselves than boys. So we got gender in here. Beta 1 S times, go back. Who's your reference category?
Yes.
Moyles, okay. Is girl, sub I. There we go. How about harming others? Gendered?
Yes.
Definite, okay, so
They're all gendered.
they're all gendered, okay.
The direction, we haven't gotten to like a bunch of interactions yet, so
Mhm.
we're not entirely sure which direction.
So what we know at this point is rates of these behaviors can differ by gender. That's what we've said. Okay, now the rest of this here. Got that one. Check. How boys and girls' stress and anxiety influence their harmful behaviors.
That would be an interaction.
So you think that stress and anxiety influence it differently?
Yes.
Okay. So there we go, beta 2. Come on. Let's go, we'll just do stress for now if that's all right. Because anxiety will look the same. Is girl. Same for all of them? Or
Yeah.
goes in all of them at least?
Them all same.
Keep them all same? That's easiest to talk about for sure. Technically that's not required, but that's easiest for the results section. Is this right, or did I forget something? Need the main effect, yep. Nope, I'm off the page. 3. Okay. So what software are you using to pull this off? Stata, okay.
For now.
For now, yeah.
We're
That-
only doing the exploratory stuff right now, just to see what's there.
Yep, okay. There we go. So we got that, just ignoring anxiety for the sake of time. Is there a gender difference in internalizing depression or anxiety?
So for me, that's a different outcome.
Ah, it is, but what if I...
Put it all in the same.
It sounds like what you are talking about to me is girl leads to anxiety, leads to harms self, something like that.
The girls are automatically
Well, anxiety is predicted by gender.
By the stressors that are.
Well, that's this question right here.
Oh, I meant.
That's not what you meant. Okay.
No, I meant is there a gender difference
In the effect
in
of?
the effect of stressors on externalizing depression?
Okay. Gotcha. Okay. So then that is a different outcome if you're trying to predict that. So externalizing depression and anxiety, what does that look like in terms of distribution? Is it a scale of some kind?
Yes, well, no, so externalizing depression and anxiety, sorry. That is the actual outcomes. So externalizing self-harm or harming others, externalizing is harming others, internalizing is self-harm.
Okay. So are we talking about...
Well, the interaction is-
Okay, so this part that's highlighted here is a synonym for the outcomes we already have, or no?
Yes.
Okay, we got that much then. And is there a gender difference? And so these questions are answered as the presence of
Yes.
interactions with these things. Okay. Who is likely to both internalize and externalize dual harmers?
Yeah.
So that's who's in this group? Is there anything else that you want to put in here besides these things right here?
Yes, there's a lot of covariates.
A lot of covariates. Do certain emotions, depression, anxiety, loneliness, influence harming behaviors more than others? So those would be the covariates?
Yes. There's
Okay.
a CESP scale, which is such a full scale. There's a Rosenberg self-esteem scale. And then there's
Okay.
the other one.
Okay, so these are scales. They're continuous variables of some
Yes.
kind, probably.
Yes.
They may have floor and ceiling effects,
Yes.
potentially, but they're predictors, so we don't care about that. Influence certain harming behaviors more than others. So are you asking if depression is a bigger predictor than anxiety?
Yes.
Okay. How did you answer that question or propose to?
We have one.
Haven't done that yet. Would you like an idea?
Sure.
Does anyone have ideas? How could she answer a question as to whether another covariate in these models, stress, anxiety, loneliness, etc., matters more? So is depression a bigger predictor than anxiety, for instance? How would I answer that question? What if I told you you've already done a question like this in a homework? I believe it was homework 1.
Do a model with each one and see which one's better?
You would have to put them both in the same model to see which one's better. You guys did this with number of papers and number of posters predicting job employment. I asked you if it was better to have one more paper or one more poster. Remember this? Remember? Now, could I just do that here? Or would that not make sense in this context? So let's add these here just for sake of argument. Beta, this will be 4p times depression plus beta 5p times anxiety. That looks like it's spelled right, okay? So I could write an estimate statement that says, is beta 5 different than beta 4? Ah, that's my question. So this is the effect of a unit of depression different than the effect of a unit of anxiety? Are these on the same scale?
They are.
They are?
Which is surprising, it's like the one thing that's the same.
Like they have the same, they're on the same form, or they have the same mean and variance?
Oh, they're on the same form, I don't know if it's.
Ah, see, this actually would involve a judgment call. If you really wanted to be able to say a unit and have a unit be like mathematically the same, you'd probably want to z-score them or do something to put them on the exact same scale. If they're on a scale where you all agree on what a unit is, even if there's more variability than one, then it might make more sense to leave them unstandardized. But that, I would be careful about that in this context. But yeah, you can answer, that's a comparison of slopes within a model. If you wanted to compare, if
So
the...
you can compare them. So with that, so if I compare those two, that's with the reference group being none, I can do it for all of them?
Sure you could. That wouldn't tell you if the effect of depression is bigger on harming self than harming others. Right? That's a different question.
Yeah.
How would I answer that question?
Isn't that with,
Or anxiety, for instance.
isn't that just a link?
I would have to say, is the effect of depression in this submodel
Yeah, you just-
different than the effect of depression in the other? And the brackets, exactly. Yep. You can compare slopes across submodels to see if it's a bigger predictor. And in
that's
that
why we chose nominals and a bunch of locals.
Mhm.
We wanted to, we wanted them all together, so we could do that.
yeah, that makes
I'm
sense.
not crazy.
You're not crazy. But so there's rarely a single right way to set up a question, a model. It's like, what do you want to know? And it looks like from your perspective, harming all is different than just saying I harm myself and I harm others. Like it's a different category. The sum is greater than the parts or that kind of thing. Yeah. Yeah. So how would this model potentially fail you if you're ignoring all the clustering? That's a question. At a minimum, these standard errors are going to be way optimistic. There are a bunch of other issues pertaining to how we represent these same constructs across time that are also relevant, and that's not something we'll get a chance to talk about in this class, but just as an example. I'm assuming that this is a typical sample where they have the same gender identity across time. In older data sets, that's probably how it was collected, and we can't change that. But something like stress, is stress something that changes over time? Or varies over time, probably? Yeah. So some people have more stress always, and then some times are worse than others, particularly in adolescence, right? So whenever you think about a variable that changes over time, this variable is actually two things. It's between person differences. Some people are more stressed than others, and it's also within person, some days are worse than others, or some years are worse than others. And so it may be the case that people who are more stressed out than others are more likely to harm others all the time. And it might be the case that your own individual risk goes up relative to your own baseline in times of more stress. Those are two different things. And so that's where the tricky part is in extending these models, not just in trying to deal with all the dependency of how each of these outcomes would be related across people over time, but also how these variables themselves have to be partitioned to reflect the time-specific components. Dissertation. Question?
So, random question. So, what if you find that correlation between the first model and the third model and the outcome are highly correlated, and the second and the third?
If what is highly correlated? I'm not sure I follow.
If the outcome you measure, you find out they're highly correlated,
Across time, or
or just at a certain time.
at a certain time. How can these be correlated?
No. I mean, it's just if you find out, you just do a correlation between the outcome, and you find out that.
I think I know what you're saying. The same person is not representative. They're only representative of that. Is that what
Oh,
you're
yeah.
saying? That's what I'm saying.
Okay.
Oh, yeah, so harm self is just harm self. Harm
Okay.
others is just harm others.
Mhm.
Harm all is harm self and others, and they're both in one. Like, you
Okay,
cannot
yeah.
be representative.
Yeah.
Is that?
But this is what bunch.
Okay.
Mhm.
So each person only belongs to each category.
One.
They are not like maybe
Yeah, you can't be like in all. Yeah.
Yes. You can only be in one of these 4 groups at one occasion,
Yeah.
right? But across time, you could move in and out of the groups, right? Have you harmed yourself
so
today?
Home is at one wave and we're controlling for all.
Okay, fair enough. Yeah, so that is an
Interpretation will be more.
yes, that is another reason, by the way, to think of modeling all of these things simultaneously, is because if you have a longitudinal model where you were predicting, say, only harm instead of none, your sample, like the people who didn't pick one of those 2, will drop out at occasions where they pick something else, and they'll come back when they're part of this submodel, and you don't want that. You want to keep everything like the same. So a simultaneous approach is probably the best for a lot of reasons. Yeah.
That, you might not know the answer to, but
Ooh,
are you,
I like those kind.
Are you familiar with the survey package data?
The SVY thingy, a little bit.
So do you think that does a decent job controlling for the cluster? Because you so basically you tell the sampling design, like the population weight, the correction factor, what it was clustered on, and then you use that prefix for all of it. Do you think that actually works, or would you say no?
I would have to look in the documentation to see exactly what it's doing. What I think it's doing is probably just adjusting standard errors for the clustering, and there has to be some sort of assumption that underlies that adjustment.
Okay.
It's probably that the type of dependency that you have is constant.
Yeah.
If that's not true, then that adjustment will not be adequate. And that also completely sweeps under the rug these issues of how the variables manifest themselves differently at different levels of sampling. So like just even between and within persons, if you go to a school that has lots of anxious people, right, does that harm you above and beyond your own anxiety? Like those sorts of things are just don't care in those sorts of approaches.
But the way you teach it,
I do care. They become the sources of dependency become random effects to be quantified and explained.
Okay.
That would be my preferred approach. But that's not this class.
Yeah.
We get our toes wet and that kind of thing. But that's come back. That's come back to the multi-level classes and the other stuff. All right. Did you have I hit all the major bullet points on this? Okay. So in your case, it's not going to be the linear model aspect that's going to be that challenging. Although arguably having 3 submodels and keeping everything straight is non-trivial. But trying to deal with the clustering and the longitudinal component and all of that, that's going to be the trickier part. So, good. Well, no one ever wanted to have a dissertation that was too easy, right? What fun is that? All right. And then Hansi, can you, let me try and see if I can turn you up. Can you turn on your microphone? Are you still there?
Can you hear me?
I can hear you. I can do a translation. Can you guys hear out there? Let me turn this up. Can you hear her?
Can you hear me now?
Yeah, you're on my laptop. I can't figure out how to broadcast it through the room with any level of reliability. So
Sorry about that.
Okay, so I'll translate. Cross-nativity marriage, so marriage between immigrant brown people and U.S.-born people, shaped political participation and attitudes of those with immigrant backgrounds. So she has data from young adults in New York City. She was able to categorize people into one of 6 categories right here. So it's whether or not you're first generation, second generation, or third generation, and what appears to be involved with, married or partnered with a U.S. partner or a foreign-born partner. And so she sent me to this, and she says, I'm not sure whether creating the 6-category group was right. Otherwise, I could have done one variable for respondents' generation, another variable to indicate U.S. versus foreign-born, and interact the 2. So let's tackle that first. What do you think? Should she have one predictor that has 6 levels, or should she have one predictor with 3 levels that interacts with another predictor that has 2 levels? So I'm just going to write out coding here. beta 0 plus, for the alternative way that she described, beta 1 times, we'll make second gen, will be my first alternative group. It'll take me a minute to write this, you guys can think about it. Plus beta 2 times beta 2, excuse me. Third gen, third, not third. This is why I don't type in front of people. Plus, so this is the alternative way of thinking about it. Number 4 would be whether it's US versus foreign born. So we'll say foreign born as the alternative group, and then having an interaction term. That's why second, third, second, third times foreign born. Okay, that's what my linear predictor would be in the alternative way of setting this up. That's 5. What do you think? You like that better? How many degrees of freedom does this model take? How many betas do I have right here in front of me? Assuming I can number them correctly. 1, 2, 3. Yeah, I can't type in front of people. Now you know why I don't do stuff on the fly very often. There we go. How many betas do I have in this little equation I just wrote here? 6. How many groups do I have? 6. Do I have to make a choice? These are equivalent. It's whatever you prefer. You could get all of these contrasts. So this beta 1 right here, given my parameterization, here's my reference group. First gen with a US partner. Beta 1, the simple main effect of second generation is going to be conditional on US partner because that's the reference. So it's going to be the difference between this one and that one. So if you picture putting this in as a categorical predictor with like 6 rows of numbers after it, that difference would be, I can do that for you. We'll say group, we would have 0, 0, 0, 0, 0, 0. That term right there is that group minus that one. Beta 1 is this group versus that one. Beta 2 is this group versus that one. So I would get that one by moving my 1 over. The simple main effect of being foreign born would be, this one versus that one. So that would go here instead. And now the interaction term, that is whether these two, the difference between these 2 rows is different than the difference between those 2 rows. And I could get that with a contrast that looked like that. So I would actually argue that keeping it 6 might be more useful because there might be some combinations that you want to compare that do not readily show up as these terms. Like if you wanted to know if first gen with a US partner was significantly different than second gen with a foreign partner, for instance. You might want to know that. That's not readily expressed in the linear model down below, but you could do that real easy with just a simple group difference up here. So it is 6 of one, half dozen of the other, literally, because there are 6 means here, and it would take 6 betas to recreate them. So, Hansi, does that make sense?
Yes, it does. Thank you.
Okay, so that part, cool. Voted in the last presidential election, yes or no? That's a logit. Do you have to do anything else but decide to make it a logit? I'll ask you guys. Binary outcome. Do you need to worry about over dispersion, extra zeros? Nope. That one's pretty much good to go. The extent to which you care about politics, or politics petitions care about me, those look the same to me. What kind of model do you think that would go with? It's ordinal. So what kind of link function do we want on that? What kind of logit? Cumulative. So this is the one that would be like agree versus something else, agree, somewhat agree versus something else, agree, somewhat disagree versus disagree. So it would take 3 submodels. And what would we have to worry about in predicting this type of outcome with, say, our 6-group variable? Do I just put group into the model and be done? Homework 2. Do you think the effective group is the same if you're predicting something lower than agree than if you're predicting something lower or higher than disagree, for instance?
Is it the proportional odds assumption?
This is proportional odds, yeah. And this is why actually I had you guys use GoLogit 2, because that was the routine that allowed you to test and specify what's known as partial proportional odds, which is where you get to pick which slopes are the same across the submodels and which ones differ. Sure. So let me pull up, rather than spending a bunch of time typing, let me go back to a slide that has this sort of thing on it. Nope, that's an example, but it'll do. I'm pulling up example 1, part 2. In this case, there were 2 submodels because there were only 3 categories. So the logit of a response greater than 0 or greater than 1. And I put in a predictive model on the first try that looked like this. So I can get it on there. Yeah. So the logit of answering something greater than I don't want to go to college is the first submodel. And the logit of answering yes, I definitely want to go to college. Look at the betas in these equations. Only the intercept differs. Beta 1, beta 2, beta 3. The notation conveys that I am assuming those slopes are the same, regardless if I'm predicting the logit of greater than 0 or greater than 1. So that is a proportional odds model. That's what it's called, because the odds are proportional to each other across submodels. I made a picture to try and show that as well, to show just predicted values across different combinations of my predictor. And the plot on the left here shows they're exactly parallel. So they go up and down together because the slopes are the same across the submodels. The 2 lines are different because each submodel starts at a different intercept for the predicted logit when all the predictors are 0. So GoLogit 2, GoLogit, go Logit. I'm pretty sure it's GoLogit, but I can't not see it as GoLogit, I'm sorry. This is where it allows you to specify separate slopes for each of your submodels. That's actually its default. And the analog to this in SAS was proc logistic with a option unequal slopes. And then you can test for every single predictor whether its slope differs across the submodels. And if so, you can decide which ones you want to keep separate. So in this case, the only one that was different was the effect of private school. And so then I rewrote the code. So for instance, in GoLogit, this option right here in parentheses, non-proportional odds, C private. So it says, okay, let that slope be different across submodels, but constrain all the others, because we did significance test and that seemed to be the most reasonable thing. In SAS, it would be unequal slopes equals private. So, yes.
So, hypothetical, theoretical question
Mm-hmm.
is why would you not immediately go to that than just assuming that they're all
I have no idea.
okay? That's why I was like, all right, so okay, that makes sense then.
In
Because
re
then you can know, and then you can keep solving on others.
it's if the slopes can be constrained, they are tested with more power if you constrain them. Because otherwise you're dependent on sample size in terms of the number of categories, because they may have differential power across submodels based on how people stack up. But yeah, I completely agree. I think the default should be separate.
Okay.
In nominal models, by the way, your data, they are separate from the get-go. I don't even know how to constrain them to be equal, to be honest, because like that's not even a thing that you do in nominal. But I agree with you. I think the default.
Maybe because the write-up might be a little more complicated than the do switch, but.
Well, the way that I would think about it is if you have a manuscript that has different columns for different outcomes where you had the same predictors, like you might have a solution for outcome A and then a solution for outcome B. Like if you just make this submodel and that submodel, then it seems to translate. It's just that you have to be clear about what you're predicting. And that clarity is the hardest part. So yeah, we do have to worry about whether or not, in this case, the effect of which group you're in differs across these submodels, and if so, be able to set up a model that has that. Do we have to worry about over-dispersion in GoLogit land? No? Extra zeros? Extra ones? Nope. Nope. Because each of these is a binary submodel. It absorbs however many zeros or however many ones there are as the mean of the binary variable. You don't have to do anything extra. I also have a series of variables that asked about civic participation. Logit are some kind of counts of types of participation. So Hansi, is your question whether or not you count up the number of things they're involved in and predict that, or whether you have a model that predicts whether they're involved in each one separately as an outcome?
Yeah, that might be more of a theoretical question, but I could do it. So are you a member of PTA or not as its own thing, or just kind of a how many organizations are you involved in as a measure of civic participation?
Okay, so do you think that organizations are all created equal?
Probably not.
Okay, then you can't add them up.
Okay.
Because
Yeah,
that's what you're saying, is that they all count the same.
Right.
And
Yeah.
if you can't justify that, then I would probably keep them separate.
Okay, that makes sense.
Yep. Got my stick out today earlier. It was the fulcrum day, so I'm playing with that. All right, so Hansi gave me some full disclosure that she submitted this as an abstract for a conference, didn't know what to do with the data, so she collapsed everything into binary. You know what? Add a girl, because you got to do something before you can do everything, right? Correct. You got to start somewhere. So don't feel bad about that. I'm happy that
Thank you.
You will have the skills to do a more thorough investigation, shall we call it, right? It's never right or wrong. It's how much you had to simplify to get through these things. And so hopefully now you have the skills to be able to use the data in a more original form rather than having to make collapsing sorts of things. So, add a girl.
Thanks.
Sure. All right. Anyone else want to play while we're at it? No? Okay, so at any point this semester, you guys are allowed to ask questions about stuff you're working on. that helps facilitate sort of an organic review and also some problem solving, right? Because when you're out in the world, you don't know what the right answer is. You have to figure out where to go. So that's just one last thing I wanted to tell you about was the end of quantile regression. But since we got on this topic, I just wanted to point out to the last slide, which I've called open in case of emergency. We haven't done anything along these lines yet, but I wanted to alert you to the possibility that there is a way in all these programs just to say, F it, just fix the standard errors. I don't know what distribution it came from. Or I don't care that it's clustered. I want you to fix it because I need to write this up and turn it in. So in Stata, for instance, on the option VCE, you can ask for standard errors that are robust to certain problems. What they are robust to, I'm honestly not entirely sure. It depends on what the documentation says. I know in the context of M+, it's robust to distributional assumptions, multivariate kurtosis in particular, but it's also times when you're not sure you have the right distribution. These sorts of standard error fixes, bootstrapping and jackknifing, these are to create empirical sampling distributions rather than use asymptotics. So it tries to create the standard error that would be reflected in your data as opposed to generalizing to some sort of distribution in asymptotics. So I would encourage you, if you're in a situation where you're not sure you've made the right answer, you don't know, like you don't have ready guidance, you can do these sorts of things in addition. Use these approaches to check your standard errors, see if your conclusions change, and if not, feel good about yourself. In Stata, you can also add a clustered standard error option, and that probably is what shows up in SVY by default, but it has been in all of these GLM models as well to correct for clustering. I hesitate to recommend that because it sort of sweeps the problem under the rug, and I would encourage you to have model-based alternatives instead of that. But this is one more thing we have in our arsenal, is just ways to fix the standard errors, even if we don't know what the right model is supposed to be. And we also were talking about quantile regression. Remember that? Why not predict the median? And if you can predict the median, you can predict anything. So what it does is instead of maximizing the sum of squared residuals, it maximizes the absolute value of the residuals. So if you just do that, that's the same as predicting the median. There's also a way that you can weight those absolute values so that you can predict any percentile that you want. So I think this is one of those techniques I wish I had learned about earlier. It seems really useful. It's a way of specifying a type of interaction between an IV and a DV. So I give you a couple examples of hypotheses that you might have. So for instance, if you have a student intervention, is that helping low-performing students more than it helps high-performing students, where performance is the DV? So like among the lower end of the distribution, is there a bigger effect of students who had the intervention versus who didn't than on the higher ends, like the kids who probably didn't need it? You would expect that to be the case. I had an example from my master's thesis I used in another class in older adults predicting response time as a measure of processing speed. Does age predict response times among slower responders to a greater extent than it predicts response time among faster responders? So does age matter on the, I guess, the positive side of the distribution, the slow people, more than that? And the example that I have for you in terms of square footage, does square footage matter more if you're selling a cheap house than a medium-priced house or an expensive house? If you're trying to decide how to remodel your house, right, you'd want to know, like, among houses that are priced near me, is adding a bathroom going to help much? As opposed to just, does adding a bathroom help if your house is already 5,000 square feet? Probably not. It already has 6 bathrooms. So this is what I wanted to show you, was predicting the median or any other percentile. So SQReg in Stata, note that I've set my random seed so that my results come back the same. This is Jenny, as we discussed last time. This is the same type of model that we looked at in predicting the mean, but now we're predicting the median. So those outlying houses that were really expensive don't have the same influence on the solution. After that, it looks like the effect of new is gone. So whether or not it was a new house had been borderline significant this whole time, it's gone. So if you have a predictor that's significant in predicting the mean, but it's not significant in predicting the median, that probably means those outliers were dragging it. I bet they were new houses and they were messing it up. Square footage still matters, but it does so only linearly. The quadratic term is non-significant. SAS and Stata, by the way, came up with fairly different answers for some of these things, and so I'm not going to have you do a homework because I don't want to wrestle with that. SAS, meanwhile, thought the quadratic trend was significant, for instance. Yeah, I know. I know. I was like, all right, I give up. I give up. But then I thought, well, why the 50th? Why not the 25th? What matters in sales prices of inexpensive houses and about the 75th? Well, to do that, SQ-reg, throw in more quantiles. I had 50 here before. I got 25th percentile, 75th percentile. Stata also has a thing that SAS doesn't have that's called IQ-reg. And that's not intellectual quotient regression. That is interquartile range regression. What it does is give you the differences in slopes across the 75th and 25th percentile. So it tells you directly, kind of like the non-proportional odds, how the gamma solution told you the difference in slopes. This one tells you the difference in slopes in that. And so it gives you the answers for the 25th and the 75th, and then IQ-reg gives you the difference in slopes. So it doesn't look like any of these matter more in one quantile versus the other, but then why stop there? Just get all of them. Stata doesn't know how to do this, or I couldn't figure it out, but SAS knows how to do this. And so these were the pictures I led with last week, and I was like, stay tuned. Da-ding, da-ding. So these pictures are from fitting a separate regression model at every single possible quantile. There's like 1,000 of them that it could find in the data, and it's tracking the change in the parameter and the confidence interval around it found through bootstrapping. So I have the right up here on the side. The intercept increases as the quantile increases. The expected sales price, say at the 80th percentile, is higher than the expected sales price at the 30th percentile. That's what percentile means, right? But this is the part that I thought was more interesting. Whether or not it's a new house, it looks like there's only a tiny bit of the distribution where the new house is reliably above zero. The further you get into expensive house land, it seems to be more noisy and less meaningful. It looks like there's a trend in terms of number of bedrooms for that to have 2. If it's 2 instead of 3, that's a higher sales price in the expensive houses, although it's not significant. I interpret that as the condo effect. That is the only possible way that having 2 bathrooms is better, or 2 bedrooms is better, is if you are in the penthouse. This one's kind of funky. This is having 4 bedrooms. It actually decreases your price, although not reliably different than 0, and then all of a sudden it jumps back up again. And these ones are for bathrooms, and this one is for square footage. So the linear effect is over here. It looks like square footage starts to matter more in the more expensive houses. Here's 0, by the way, so square footage always matters. And here's the quadratic effect of square footage. So it looks like there's an acceleration that is once it crosses this 0 line, and it only becomes significant in this range right here. So if you want to know if your predictor affects people differently at some points of the distribution, this is your thing. Cool? I think so. And it also doesn't really have distributional assumptions because it doesn't rely on maximum likelihood. It's a different sort of search algorithm that's going through here, and the standard errors are not based on asymptotics, they're based on resampling from your sample. So it's safer in that respect. I think it does make most sense if it's a quantitative outcome. And as always, words. Although I gotta be honest, I was just totally flying blind in this one because I've never written up anything for any of these models, and I just said this is what I think it would look like. So, there. In particular, the quantile stuff. So, I did give you an article on quantiles, didn't I? Yes, I did. On the syllabus, and I added it to Icon. Question?
Oh, I was gonna ask if next time we could get another example of a different outcome that we can use for. We don't have to, we don't have to. If the article has it, I can just read the article.
Yeah, I don't have any more. That's the problem. But I gave you let me go back to the website. Which one is it? It is, I added it, it is this guy. Constantinopolis. I believe that's the one. Let me double check. I may be making this up. Yep, yes. This.
Okay.
Educational and psychological measurement using quantile regression. There's your other example. Asked and answered. So, all right. Any other questions? All right, then I will let you know once I have handouts ready for Tuesday or what else the plan is instead if I can't get that done. I'll be honest with you. So have good weekends. Office hours start now if you want to stay and hang out and talk about homework. So I will see you all later.